Peter Hill Explains, where I invite you to join the science teaching conversation with me about matter. Another easy lesson, I hope, for you. I've given lessons or podcasts on light, energy, mass, and now I'm going to talk about matter. And you might ask yourself, or I'm asking myself, why am I giving so many podcasts so quickly off the cuff? Well, I'm developing this is an aside, I'm developing a podcast, YouTube, hopefully to Facebook and beyond, and Twitter engine to take podcasts, so I can do a podcast per lesson and get it edited and out to the students before the lesson, so they can actually listen to the podcast as they're coming to, and other things like integrated apps like it is. So I'm sort of familiar to this stage of development. You've worked on a robot or something for a couple of days, and you've finally got through to the other side. And this one, I've just got these insane stories that I remove a bit of code and another piece of code which are running parallel, runs too fast. So I've put out a few YouTubes with the wrong label on the artwork. And as I'm saying, I'm going to have to write something that interprets the title and places it on the artwork a bit more simply. And I think I can do that. And I've just gone through, and some of the YouTubes don't upload. The YouTubes complain, so I've just got in and talked about the codecs. So that this is the streaming for the YouTubes and stuff like that to get it going. So that should be faster. And it goes through this really, I almost call it a grumpy stage of software development. But I think I'm doing about the right thing. I'm doing about 50% podcasting to produce stuff for it. So I've got to produce enough podcasts for it to actually chew it up and put it out. And so there's there's still sort of annoying gaps in terms of I have to open up every blog and write the E tag into it and transmit it across. There's still things I don't know. I don't know whether I can actually put streamlined MP4 file as my podcast file. I have to look at that. I somehow don't think players are going to play. I'll be interested. I might put a MP4 file on my dictaphone as my only device. Look, I've got really no technology. I've got a really old mobile phone, just one computer. And normally what I would like is, like, if I've got a series of, like, a few computers all running the same program, but one watching the other one. So if the other one hangs, another computer can come in on it. So let's look at matter. Now, various people will flick over my philosophy talks, but matter is really rooted in philosophy, ancient Greek philosophy. So matter comes from the Greek word for matter comes from the idea of wood. If I want something, I can carve it out of wood, and matter means origin. And then the Romans, the Latin people came over and said, your origin is your mother. So matter actually comes from the word mother, and it's refers to an object. An object is made of matter. So matter is not a fundamental property of matter. There you go. Matter is what's inside an object. So you've got Aristotle's various causes, and essentially you've got basically the idea of an object, a conceptual object, which is, if you'd like, a computer matrix of this surface, and inside the surface fills is this amazing bird just opposite me. Oops, it's gone down. Oh, okay. So it's sorry. This is one of the distracting things of being out in the Blue Mountains. You've got all this wildlife just hopping around, and they seem quite tame. Look, this one's it's a kookaburra, but it's sort of a cross between a kookaburra and some other birds. It's got the same. It's much smaller than a kookaburra, and it's actually, sorry for giving this up over here. It's over here, and it's got a really complex call. Very intelligent bird, and it's off. It's just, I don't know why. None of the actual birds and wildlife are all that much frightened of you, except wallabies, but kangaroos will come up to you around here because they're all tame. Okay, getting back to matter. So if you imagine a injection molded, blow molded toy which is hollow on the inside, which is the out shape form inside the object, the people believe there was matter. For a long time people didn't know the difference between, or couldn't, trying to pull apart the difference between matter and mass. And mass was basically, mass sort of fell into our laps as a concept, as a property of matter. So matter is not a property of matter. Matter is a way of referring to something. So matter is more like a shopping list, whereas mass is a number. So the mass of something or other is 8 or 7 or 2.713 or something along those lines. That's what the mass is. So the mass of something. So the mass is a property, a measurable property. You can't actually measure. Yeah, you can't measure matter. Matter is a conceptual thing dating back before mass. Mass was introduced by Giles of Rome, attempting to work his way through. He had Plato and Aristotle on one hand, he had the Bible on the other. And the Bible was saying that this substance transformed to another substance, transubstantiated. Well, there you go, it's transubstantiated, which refers to the idea is conceptually. It doesn't physically, does it? Conceptually does it? All this. So we had the two together, and the result of trying to put these completely opposing thoughts together, out popped a third thought of mass, way ahead before we knew anything to measure with it. We're talking about matter. Imagine a cube in space, and and I will call that cube my handbag or something like that, and in it's got a certain amount of matter. And so it's now there's a really annoying definition which gets trotted out by people who they always, as soon as they say it to me, they smile afterwards, which is just makes it doubly annoying. People say mass is the amount of matter in an object. I'll break my teeth off to hear people say that. I think that may be the official definition of what mass is, but we know a little bit more about it now. And in an object is a conceptual boundary. So I've got in front of me logs. That's got a shape to it, and the amount of matter. What they actually mean is the amount of particles inside it: electrons, protons, neutrons. It will also contain, I suppose you would call, photons inside it, because it's hot. There's a photon gas inside that log there. You can't see it, but I can see the gas leak away if I had an infrared image of it. And there'd be a few neutrinos in there. So that's ordinary matter. So matter comes in several, we have subdivisions of matter. So if I can say, there's normal matter, antimatter, dark matter. I assume, because no one knows what it is, I assume there would be normal dark matter and normal and anti-dark matter. I would assume whatever that is, because that dark matter also has mass. It's a bit hard to try and figure out exactly what that means. And so the object inside has. We say, look, we're not counting antimatter, and so in the case of, say, if we make something which decays into antimatter, that changes and that matter is lost. It's sort of a bit hard to say. So look, matter. So a particular particle, a hydrogen atom, for instance, is matter, and positron is antimatter, and these things, even say like if I have something as benign as a neutron decay, beta decay, that actually produces a quantity of matter, which is from nowhere. An electron is produced, and a neutron is turned into a proton. So it gains a positive charge. There's a negative charged electron out there that produces the electron. There is a piece of antimatter produced. There you go. It's an anti-neutrino. You can't just get a lepton from nowhere. You've got to actually summon up an anti-lepton with it. So even normal decay is just juicing out something called antimatter. So that's a bit of a head scratcher across. And of course, antimatter knows certain things about the symmetry of antimatter, that if we introduce antimatter to matter, the entire thing unfolds and produces two photons of light, two opposing photons of light. So we know that much. And we also know, in terms of the way that the Feynman diagrams are drawing, that antimatter are particles in reverse symmetry to matter particles, and they're travelling backwards in time. So what does that exactly mean? I find that a bit hard to actually comprehend. So, an antimatter person built an entire person out of antimatter, would that person undergo, besides it blowing up, but would that person start to actually, as a whole, in all actions, go backwards in time? Because there's interactions. I just find that a bit hard to comprehend from my understanding of entropy and stuff like that. But we know that antimatter does go back in time. So an antimatter positron is an electron travelling backwards in time. That's a bit hard to swallow, getting macroscopically. So what is matter? Well, I can have a ton of steel or a ton of feathers, which is heavier. And I say, look, a ton of steel will tip the scales to a ton of feathers. And this is an age-old thing that the kids like to play. They like pen, pineapple, and shooketh, and all these other things in. But indeed, feathers are more buoyant because they're submerged in the atmosphere. So if you took them into deep space, yes, and put them in a gravitational field, yes, they would weigh the same. But space, if you said weight is what you measure on scales, it's there. So in fact, it's hard to say, if you've got some marshmallows, you can actually get a greater mass of marshmallows for the same weight of marshmallows, because it's more buoyant. And of course, this is a thing to do with things. But let's get on to matter. So two objects are distinct. Well, this is getting philosophically. If I have if I show you, I don't know, I want to upset people, but let's make it. If I show you a kitten and say it's a mass of 1 kilogram, it's a normal kitten, it's a kitten, it's not too big. Later away, I show you it has got the same, a puppy, which has got a mass of 1 kilogram. That's okay, because it means the property of those particles is the same as the property of the mass of each of the individual particles sum across the two things. However, if I showed you a kitten and said, I'm going to go and show you a dog of the same matter, that would be a very concerning thing, because it would mean that it would have to have exactly the same number of protons, phosphorus. It's got to be the same. I've got to rearrange the atoms. So something matter is neither created nor destroyed is not necessarily a mathematical thing. This is Lavoisier's in a chemical reaction. I would be able to chemically change that kitten by, say, baking it in an oven, and out would come a puppy. The matter is the same. The matter is the same before and after. It's a rearrangement of that matter, which is the number of protons. I could say that the matter is the same, because you're allowed to say that in quantum mechanics. That hydrogen is the same as that hydrogen, because in our universe, and this is one of the things as you're wading through Nicholas Stokousa, you say, oh my goodness, thank goodness we didn't he didn't survive. He didn't live another, what would have been another 600 years for to find out about quantum mechanics, because that would have really done his head in. But a hydrogen atom and another hydrogen atom, they are identical. That's because they can, I suppose they're entangled or something like that, but they are physically absolutely identical because they can't have the information associated with them. So you could put a tag on it. You can't tag an electron and come back to it and tell where it's from. This is something, it's just a bit mind-bending for me occasionally when I look at ocean or something big. I say, that's a hell of a lot of hydrogen and oxygen all mixed together. But to a certain scale you can tell what is separate, but these things are absolutely identical. So you could have a cat, a kitten and a puppy. They could have the same mass. If they've got the same matter, it says that the shopping list of fundamental particles which I have for that cat, if I had it as a recipe of the cat, you have so many, I suppose we've got 600 trillion neutron. Oh, I can't do it in my head. I could do it something in my head, but there'd be a couple of billion trillion of this element and a couple of billion trillion of that element, all adding up. I'd have to do it mathematically in my head. I'm not up to that at the moment. And that's my shopping list. Okay, and you can build it to a different recipe, but you take it over here and the recipe to make that puppy is the same. Now, what you could do is the matter would be conserved, and if you could chemically react that kitten to be a puppy, you would say matter is conserved. You cannot create or destroy mass, which I don't like. Mass is something is frame dependent as well. Matter is not frame dependent. Just get that into your head. So I can increase the mass of something, and I regularly do it in the old telly sets. I don't know if anyone still has them out there, the old cathode ray sets. Your little electron would be going, I'm not going the speed of light, no way mate, and it lolls around and gains some mass and doesn't speed up as much before it hits in. You punish that electron by actually slamming it into a phosphor, and you just enjoy the light coming out of it. There's more to the TV than the actual physics of it, but it is quite interesting watching television and seeing all the physics switch on and all especially the LCD screens and LEDs and all that beautiful polarization happening at the moment. So mass is frame dependent, but matter is not, because matter is the shopping list of fundamental particles in it. So if a spaceship goes right past the Enterprise, the USS Enterprise, as they're going around. Thank goodness they're not here on Earth. I think that's all I can say. They're going around with Spock and all those people who fly across. As they fly across, you can see the gravity waves and all that type of stuff, and their mass increases as they're travelling very fast relative to us, because mass is relative, as in length and all these other aspects are. But the amount of matter there is the same, because really I could say, look, here's a group of fundamental checklists, the manifest of who's on the Enterprise. Well, I could lump those together and say, I'm going to call that lump that actor. They're not real actors, they're real people. Spock, and I remember the Doctor and the engineer, and there's Spock. I really have forgotten all that type of stuff. But the actors, just to make it really simple, the actors are the same before and after. They don't suddenly have an extra character put in there, because that's what you need to do to have the extra shopping list of atoms. And really, this is a bit of a challenge. How do you, it's something that you understand over years and years of looking at it. I'm not saying, what are you doing today? Or, honey, goodbye, I'm going off to learn about matter and mass, and they're going to pay me. It's something you learn just on the time as you sort of consider people's answers and what they say. So you learn it over a period of time, and then sort of things get you to really go back into history and sort of look at what the heck is going on, especially this transubstantiation business for working out where mass is, and the fact that mass was something that people avoided describing. Mass really was the elephant in the room as far as Newton was concerned. And when you look at it, these people were not concerned with mass because they didn't know what it was or couldn't define it. They were more concerned with momentum and impetus and stuff like that. So for every action, which is the force of an action, gives momentum to an object. So it was all in that level. And so even the process of people trying to describe it by thinking that, look, I'm translating Newton into mathematics. Well, the reason Newton didn't write it in mathematics because he didn't have it at that point of time. So mass itself really didn't have a symbol or a mathematical sort of life until the maths came afterwards. A lot of these ideas of matter and mass came from the ancient world, and the ancient world, one thing it didn't do is it didn't have a complete mix of variables that we do in terms of for instance, never understood speed, or at least they didn't communicate in speed. They didn't say, I'm going at a speed. There was no concept of speed. There was a concept of distance and time and how much distance you would travel on a time. But because these were different things, time was one thing and distance was another, they couldn't actually divide the two together. There was actually no division. Well, there's definitely no division. There's no. If you actually read Latin and I can't do Greek. I can't even do the symbols of Greek. But you look at the language, and the language simply isn't there to support the modern scientific concepts. So I hope that's a little bit of a discussion about matter, and I'll put this onto my podcast engine and see how it goes. And I've reached 22 minutes, which is ideal. I'll be able to see file size for it. I'm sorry if I find this interesting, but I'll get the flow of information out there, and that's something that doesn't fascinate me anymore. I sort of go through it. I'm sort of fascinated by how these concepts came up and how we're not necessarily worked out a good way of teaching it at the moment. Thanks a lot for listening. Another podcast, another story comes to a close. It's been a pleasure sharing this moment in time with you. May you discover truly amazing things, understand them, and tell others. Thanks for listening.